Here's Lab 3 and the mass of a black hole. In Lab 3, we had to determine the mass of a black hole based on information we were given. The information that we were given included the position of the star, the mass of the star, and the time step. We also looked at the perpendicular and parallel forces to determine the F-net. Using V idle and Newton's law of universal gravitation, I was able to determine that the average mass of a black hole was 5.77 times 10 to the 31st kilograms. The key physics principle that was used in the lab was Newton's law of universal gravitation. This law states that there is an attractive force between the two objects that's proportional to the mass of the two objects and is inversely proportional to the distance between the two objects squared. Below I pointed out what each letter will be according to our problem. To find the mass of just the black hole, we have to rearrange the equation as shown. Since we will have all of the appropriate numbers, we will be able to solve for the mass of the black hole. We also know that F-net is equal to the sum of the perpendicular and parallel forces. We then turn to V idle. We set up our scene. The thing that is of most importance here are the arrows. Arrow 1 is the net force, which will be a yellow arrow. Arrow 2 is the perpendicular force, which will be a blue arrow. And arrow 3 is the parallel force, which will be a black arrow. We then insert the given information. My given star mass was 4.7159 times 10 to the 27th. The black hole position was a vector of negative 2 times 10 to the 10th, 4 times 10 to the 10th, and 0. And delta t is equal to 86,400 seconds. I put the gravitational force constant here as well, which is represented as big G. The last thing that we are given was the star's position, which was the stardata.csv file. The next part of the code was given to us. It calculates the velocity from the data that was given in the star data file. We then turn to the next while loop. The first line of code is where I started a list for the mass of the black hole so that I would be able to find the average mass. The next part of the code is where the initial and final velocities are calculated. This was already coded for us. We then look at the initial momentum and the final momentum. Initial momentum can be found by taking the mass of the star times the initial velocity. And the final momentum can be found by taking the mass of the star times the final velocity. We then look at the star's change in velocity and change in momentum. Change in velocity is found by final velocity minus initial velocity, and change in momentum is found by final momentum minus initial momentum. We are then able to determine the change in momentum over change in time, which is equal to delta p over delta t. This is then equal to F-net. This states that F-net is equal to the change in momentum over change in time. Since net force is a conceptual idea, this is how we are able to put a number to it. The next part of the code calculates the F-net parallel. Our p hat is equal to the initial momentum divided by the magnitude of the initial momentum. Then we take the magnitude of the final momentum and subtract the magnitude of the initial momentum, and then divide all of that by our delta t. Once we get that answer, we multiply it by our p hat to get the parallel force. Once we have the parallel force, we can find the perpendicular force since we also know the net force. So the perpendicular force is calculated by taking the net force and subtracting the parallel force. Next is where Newton's law of universal gravitation comes in to determine the mass of the black hole. As shown earlier, we had to rearrange the original equation to just find the mass of the black hole. This is found by taking the magnitude of the net force and multiplying it by the magnitude of the star's position minus the black hole's position, which is all squared, and dividing it by the gravitational constant and the mass of the star. The mass of the black hole was then printed, along with the average mass of the black hole, which we used a list that we created to calculate. We now will take a look at the model that we ran in V idle. So here as it goes around the black hole, I previously mentioned that the net force is going to be the yellow arrow, the perpendicular force is going to be the blue arrow, and the parallel force is going to be the black arrow. So as it comes to an end, here's the last bit of what is printed out, and as you can see, there are two answers at the bottom. The first one is the average value for the mass of the black hole, and then the second one is the final mass of the black hole. I know that the mass of 5.77 times 10 to the 31st kilograms is correct, since when submitted to WebAssign it was the correct answer. This would mean that the model successfully predicts the mass of the black hole. On to the questions. For the what does it mean? We need to discuss how the F-net perpendicular parallel and are different from the delta p over delta t's. And they are different because force is looked at as a conceptual concept that we are not able to strictly define by an exact value. This is where delta p over delta t comes in. It is from delta p over delta t where we are able to come up with an exact number to describe the forces. We are able to see momentum changing and time changing as the position of the star changes. This is why we use it to describe the net, perpendicular, and parallel forces. On to the second question for the what if. If you were to insert a different black hole into the same location, you would not be able to tell a difference due to the fact that the motion of the star is the same. Since the motion is the same, you will find the same mass as what you originally found. Thank you.